Okay, there were some requests for a video on your reflection from the last class. So for a limit to exist, so for the limit to exist, so we'll talk about what it means for a limit to exist. Does the function need to be defined? So we'll talk about what it means for a function to be defined. Now, for both of these things, it's really important that we're saying at a certain x value. So for the limit to exist, when we talk about that, we wouldn't say the limit exists for a function as a whole. We would say that the limit exists at x equals a number. Or we might say the limit exists when x is on an interval. So the limit exists everywhere between a and b. You could also say it exists for the entire domain, but you have to specify the x values. Okay, so we don't just say the limit exists of a function, period. Same idea with function defined. A function is either defined at x equals a, or it's defined on all of the points, the x values in an interval, or it's defined on the entire domain. But you don't just say a function is defined, period. You always say a function is defined at a value. So let's look at this function f of x and consider the point where where we plug in c for x. This function is undefined at c because there's no y value at c. Let's pick this point, I'll call it d. This function, I don't know what the value is, but it is defined at d. Okay, so it's undefined at c, but it is defined at d, whatever it happens to be. It's a number. It's whatever this y value is right here. Let's call it L. So f of d would equal L. Okay, so the function is undefined at c because of the hole, but it is defined at L. Another way a function is undefined is if there is an asymptote. So if you had a function that looks like this guy over here with an asymptote right here at c, this function, I don't know where that circle just came from, this function would also be undefined. So that's what it means for a function to be undefined. And again, we speak at each point in particular. Now on this graph, the function is defined from c to infinity and from negative infinity to c, but it's undefined right at c. Now, what does it mean for the limit to exist? For the limit as x approaches c to exist, okay, that means that the limit as x approaches c from the left has to equal the limit as x approaches c from the right. Okay, now the limit, oh look, I didn't mean for these to be the same height, but let's just pretend that these are exactly the same height, and this is also L. So f of c is undefined, but the limit as x approaches c from both sides is the same y value, let's call it L. So the limit equals L. So in order for a limit to exist, the function does not have to be defined. So you can have an undefined function where the limit exists. So an undefined function, okay, where the limit exists. So that's entirely possible. Another thing that you can have, let me just erase all of this because I just thought of it, is you could also have a function where the function is defined, but the limit does not exist. So let's say we have this function right here. So we're at c. The function here is defined at c. It equals whatever this value is right here. So the function is defined. However, because the limit as x approaches c from the left of f of x is not equal to the limit as x approaches c from the right of f of x, the limit as x approaches c of f of x does not exist. So again, in order, the function being defined and the limit existing are, we would say, mutually exclusive. You don't need one to have the other. Just because you have one doesn't mean the other is there. They're two totally separate ideas. Sometimes the function is defined and there's no limit. Sometimes the function is defined and there is a limit. Sometimes neither, sometimes both, one or the other. So again, they're mutually exclusive. They don't depend on each other.